Electrical safety resources for branch circuit breakers include manufacturers' technical data sheets. Westinghouse data sheets can be found online. Square D, also known as Schneider Electric, data sheets can be found online as well. Siemens data sheets can also be found online. Industry standards and guidelines are also important. The National Fire Protection Association (NFPA 70) National Electrical Code (NEC) Section 240.833 requires branch circuit breakers to open within specified time current curves. Underwriters Laboratories (UL) Standard 489 is a standard for molded case circuit breakers and defines minimum requirements for circuit breaker performance, including time current characteristics. Online resources also exist. The Electrical Safety Foundation International (S3) provides educational materials and resources on electrical safety. An arc flash hazard analysis of handbook includes information on circuit breaker performance in arc fault conditions. Time current curves provide typical ranges. The following information provides approximate time current curves or short circuit tripping range for 20 amps and 30 amps branch circuit breakers from common manufacturers. These are estimates and actual values may vary depending on the specific model and test conditions. For Westinghouse, a 20 amps breaker has a short circuit tripping range of 0.3 to 0.6 seconds at 10 kA. For Westinghouse, a 30 amps breaker has a short circuit tripping range of 0.2 to 0.5 seconds at 10 kA. For Square D, a 20 amps breaker has a short circuit tripping range of 0.25 to 0.55 seconds at 10 kA. For Square D, a 30 amps breaker has a short circuit tripping range of 0.2 to 0.45 seconds at 10 kA. For Siemens, a 20 amps breaker has a short circuit tripping range of 0.3 to 0.6 seconds at 10 kA. For Siemens, a 30 amps breaker has a short circuit tripping range of 0.25 to 0.5 seconds at 10 kA. These ranges are for illustrative purposes only and may not represent the exact performance of all breakers. Circuit breakers may not trip immediately in arc fault conditions unless they are specifically designed as arc fault circuit interrupters, or RSIs. Always refer to the manufacturer's technical data sheets for specific information on circuit breaker performance. Electrical workers should always wear appropriate PPE when working on live circuits. Understanding branch circuit breaker timing involves several key aspects. Firstly, manufacturers' technical data sheets are crucial. These sheets provide detailed specifications and performance characteristics for specific breaker models. You can typically find these on the manufacturer's website. For instance, Westinghouse, Square D, which is also known as Schneider Electric, and Siemens all provide technical data sheets for their circuit breakers online. Secondly, industry standards and guidelines play a significant role. The National Fire Protection Association (NFPA 70), also known as the National Electrical Code (NEC), sets the standard for electrical safety in the United States. Section 240.833 of the NEC specifically addresses the requirements for branch circuit breakers, mandating that they must open within specified time current curves. These curves define how quickly a breaker should trip under different overcurrent conditions. Underwriters Laboratories UL Standard 489 is another critical standard. It outlines the minimum performance requirements for molded case circuit breakers, including their time current characteristics. This standard ensures that circuit breakers meet certain safety and performance levels. Thirdly, online resources offer valuable information. The Electrical Safety Foundation International (SV) provides educational materials and resources on various aspects of electrical safety. These resources can help you better understand circuit breaker operation and safety practices. Additionally, arc flash hazard analysis of handbooks contain information on circuit breaker performance in arc fault conditions. These handbooks provide guidance on assessing and mitigating arc flash hazards. Time current curves are essential for understanding how circuit breakers respond to overcurrents. These curves plot the time it takes for a breaker to trip against the magnitude of the current flowing through it. The curves typically show that the higher the current, the faster the breaker will trip. For example, a 20 amps breaker might trip in a few seconds at 100 amps, but it could trip in milliseconds at 10,000 amps. The following approximate time current curves or short circuit tripping range for 20 amps and 30 amps branch circuit breakers from common manufacturers are just estimates, and actual values may vary depending on the specific model and test conditions. For a Westinghouse 20 amps breaker, the short circuit tripping range is 0.3 to 0.6 seconds at 10K. For a Westinghouse 30 amps breaker, the short circuit tripping range is 0.2 to 0.5 seconds at 10K. For a Square D 20 amps breaker, the short circuit tripping range is 0.25 to 0.55 seconds at 10K. For a Square D 30 amps breaker, the short circuit tripping range is 0.2 to 0.45 seconds at 10K. For a Siemens 20 amps breaker, the short circuit tripping range is 0.3 to 0.6 seconds at 10K. For a Siemens 30 amps breaker, the short circuit tripping range is 0.25 to 0.5 seconds at 10K. It is important to note that these ranges are for illustrative purposes only and may not represent the exact performance of all breakers. Circuit breakers may not trip immediately in arc fault conditions unless they are specifically designed as arc fault circuit interrupters, RFCs. Standard circuit breakers are designed to protect against overloads and short circuits, but they may not respond quickly enough to prevent damage from an arc fault. RFCs, on the other hand, are specifically designed to detect and interrupt arc faults, providing an additional layer of protection. The electrical workers should always wear appropriate PPE when working on live circuits. PPE, or personal protective equipment, includes items such as arc-rated clothing, gloves, and face shields. This equipment is designed to protect workers from the hazards of electric shock and arc flash. In summary, understanding branch circuit breaker timing requires a combination of knowledge about manufacturers' data, industry standards, online resources, and time current curves. It is also crucial to remember that standard circuit breakers may not provide adequate protection against arc faults, and that size and PPE are essential for electrical safety. Now let's delve deeper into the technical aspects of circuit breakers and their operation. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by overcurrent or short circuit. Its basic function is to interrupt current flow after a fault is detected. Unlike a fuse, which operates once and then must be replaced, a circuit breaker can be reset, either manually or automatically, to resume normal operation. Circuit breakers are made in varying sizes, from small devices that protect individual household appliances up to large switchgear designed to protect high-voltage circuits feeding an entire city. The main components of a circuit breaker include the contacts, the operating mechanism, and the tripping mechanism. The contacts are the conductive parts of the breaker that make or break the electrical circuit. They are typically made of a highly conductive material such as copper or silver alloy. The operating mechanism is the system that opens and closes the contacts. This can be a manual lever, a solenoid, or a motor-driven mechanism. The tripping mechanism is the heart of the circuit breaker. It senses overcurrent conditions and initiates the tripping action. There are two main types of tripping mechanisms: thermal and magnetic. Thermal tripping mechanisms rely on the heating effect of the current to trip the breaker. A bimetallic strip is heated by the current flowing through the circuit. When the current exceeds a certain level, the strip bends due to the difference in thermal expansion of the two metals. This bending action triggers the tripping mechanism, causing the breaker to open. Thermal breakers are designed to protect against overloads, which are sustained currents that are higher than the rated current of the circuit. Magnetic tripping mechanisms use an electromagnet to trip the breaker. When the current exceeds a certain level, the magnetic field generated by the electromagnet becomes strong enough to attract a lever or armature. This action triggers the tripping mechanism, causing the breaker to open. Magnetic breakers are designed to protect against short circuits, which are sudden and very high currents that occur when there is a direct connection between 2 points in a circuit. The time current curve is a graphical representation of the relationship between the current flowing through a circuit breaker and the time it takes for the breaker to trip. This curve is a key characteristic of a circuit breaker and is used to determine its suitability for a particular application. The time current curve typically shows that the higher the current, the faster the breaker will trip. This is because high currents generate more heat in the thermal tripping mechanism and create stronger magnetic fields in the magnetic tripping mechanism. The time current curve is also affected by the ambient temperature. At higher temperatures, the thermal tripping mechanism will trip faster, and the magnetic tripping mechanism may also be affected. Therefore, it is important to consider the ambient temperature when selecting a circuit breaker for a particular application. Arc fault circuit interrupters of size are a special type of circuit breaker that are designed to protect against arc faults. Arc faults are dangerous electrical faults that can cause fires. They occur when there is an unintended arc of electricity between two conductors. This can happen due to damaged insulation, loose connections, or other factors. SIs work by detecting the unique characteristics of arc faults. They can distinguish between normal arcing, such as that which occurs when a switch is opened or closed, and dangerous arcing that indicates a fault. When an SI detects an arc fault, it quickly trips the circuit, preventing a fire. There are two main types of SIs: branch circuits SIs and outlet circuit SIs. Branch circuit SIs protect the entire branch circuit, while outlet circuit SIs protect only the outlets on the circuit. SIs are now required in many areas of the home, such as bedrooms, living rooms, and dining rooms. This requirement has significantly reduced the number of electrical fires caused by arc faults. Personal protective equipment, PPE, is essential for electrical workers who work on or near energized equipment. PPE includes items such as arc-rated clothing, gloves, and face shields. Arc-rated clothing is designed to protect workers from the intense heat generated by an arc flash. It is made of special materials that resist burning and melting. Gloves are used to protect workers from electric shock. They are made of insulating materials that prevent current from flowing through the body. Face shields are used to protect workers from the flying debris and intense light generated by an arc flash. They are made of impact-resistant materials that can withstand the force of an explosion. In addition to PPE, electrical workers should also use insulated tools and equipment. Insulated tools are designed to prevent electric shock. They are made of non-conductive materials that prevent current from flowing through the tool. Insulated equipment includes items such as rubber blankets and line hoses. These items are used to cover or isolate energized equipment, preventing accidental contact. Electrical safety is a critical aspect of electrical work. It is important to follow all safety procedures and guidelines to prevent accidents and injuries. This includes wearing appropriate PPE, using insulated tools and equipment, and energizing equipment before working on it. By following these safety precautions, electrical workers can protect themselves from the hazards of electricity. The information provided is a general overview of branch circuit breakers and electrical safety. It is important to consult the manufacturer's technical data sheets and applicable codes and standards for specific information on circuit breaker performance and safety requirements. It is also important to receive proper training and certification before working on or near energized equipment.